Hello, ladies and gentlemen. Mr. Miller here again for your 2-2 notes, solving inequalities using addition and subtraction there, which at the tail end of our 2.1 notes, we did a little bit of that as well. So here's two things that we're looking for. Obviously, the first one is solving inequalities using addition and subtraction. And I like to abbreviate, so add and subtraction, SUBT. So obviously that's the first thing, that's the main thing here. But also using inequalities to solve real life problems. So using inequalities to solve real life problems. So we'll use one of those here on the story problem on the back. So solving inequalities using adding and subtracting, ladies and gentlemen, is almost identical to solving just a single variable with adding and subtracting when we have an equal sign. All right, so there's not much different, obviously, besides the graphing of the solution as well. You can check your work on these as well. I'll go through that with you. Actually, we'll do probably the first three here, and then we'll let you do the second two on your own there. But starting here, so x minus 9 has to be less than or equal to 3. So, like I said, just pretend like this inequality sign is like an equal sign for adding and subtracting. So I need to get this minus sign off from the left. So it is a negative 9. So to get it from the left, we're going to add 9 to both sides and then clean it up. So x is less than or equal to 3 plus 9, which is an answer of 12. Again, you can check your work, which is a little different on this. You want to pick a number that is less than 12 here. So I always like to pick numbers like, for example, if something's less than a positive number, I always use 0. You can use any negative numbers in here, but I like to check. So with my check, I'm going to let x equal 0 because 0 is definitely less than or equal to 12. And again, with the equal sign here, 12 should work as well. If we put in something like 24, that's going to fail. All right, so here's what we're looking for this to stay true. So if x was 0, I put my 0 in there, 0 minus 9, that has to be less than or equal to 3. Cleaning it up, minus 9 is less than or equal to 3. So I know for a fact that answer is correct. All right. So like if I put a larger number in here than 12, it's going to fail. So, if we put in 13, 13 minus 9 is 4. 4 is not less than or equal to 3. So that would, it's an incorrect statement. That's failing. So here, graphing it out once we know what we have. Again, my little cheats. Mr. Bertel or Mr. Inch might want you to do this a different way, maybe graphing it. But for me, I'm going to put 0 down and then my two answers, 12 and the minus 12. And again, we're at 12 with an equal sign, so that means fill it in. And I always like to do them above. Some examples I know in the past we've done in the number line, but I like to do it above it. So we have that 12 there. And again, our cheat, as long as our variable is on the left, the arrow is actually already pointing. The arrowhead is pointing for us. All the answers there. And again, just check. 0 is my check. That's a part of my shaded area here going this direction. So we're all good. Moving on to the next one here. M minus 3.8 is less than or equal to minus 1. So again, we got to get rid of the negative sign here. So we're going to add 3.8. I'll add 3.8. Clean it up. So sometimes I like to do the line there to clean it up. So m is by itself. Keep the sign exactly the same. That's our less than sign. And then just recalculate here. So I have a minus 1 and a positive 3.8. So that is going to give us a 2.8 answer. And again, you might jump down to the graph, 0, 2.8, and a minus 2.8. We're at 2.8. It's an open circle. And the arrowhead tells me as long as my variable is first, we're going to go to the left. The same arrowhead. So again, I can check my work, see if I've graphed this out correctly. So again, 0 happens to be one of my checks. So I'm going to use the check of m equals 0 to see if it is a true sentence. So 0 minus 3.8 has to be less than minus 1. Minus 3.8 is less than minus 1. So we are good. I'm actually going to change it up because I just realized that these first 3 are all subtraction. So I'm going to actually let you do this last one on your own. Now we'll check that. I'll have answers available for you to check that. Here, let's do an addition one. So now we have our y plus 5 is greater than 6. So again, just treat this like an equal sign for right now with adding and subtracting. So we just need to get rid of the positive 5.5. So subtract 5.5 from both sides. So we get y is greater than, and then 6 minus 5.5 is a 0.5 answer there. From there, again, 0, and then I do 0.5, and then my minus 0.5. We are at 0.5. It is going to be an open circle, and the arrow, as long as my variable is first, arrowhead is there. So we're going to go this way. So notice on this one, I can't check because 0 should not be my answer. All right, so I need to check something that is greater than 0.5. So I could check 1, I could check 2, 3, whatever. 1 million if you want to check that. Let's go ahead and check 2. So my check here is going to be y equals 2. So if I plug that in, 2 plus 5.5, that has to be greater than 6. And 7.5 is greater than 6. So yes, my y greater than 0.5 is correct. I'm going to let you do that last one there also. We'll provide those answers for you. But we want to get to the second part from up here, which was using the inequalities to solve real life problems here. So flipping over, it is a real life problem, electricity. You might not think of this or have thought of it, but yes, there is only so many watts that one line, one circuit can carry. So you got to be careful on how many things are on that and using it. Otherwise, power goes out because there's safety precautions built in, or at least hopefully they are built in. So here it says we have a circuit overloads at 1800 watts of electricity. So for me, my circuit, I'm going to make that the X. All right, because the first thing here it says write and solve the inequality that represents how many watts you can add to a circuit without overloading it. All right, so we're going to do that. So right now, just reading this first part of the sentence, I like to start to set it up that way. So here it has overloads at 1800 watts. So that means when it hits 1800 watts, it's overloading. So we want to keep it underneath 1800. So it cannot be an equal to. So we're talking X has to be less than 1800. So continuing, you plug in a microwave, that oven that uses 1100 watts of the circuit or electricity into the circuit. So here we're going to now write our original equation, and then we will solve it with the second part of this information. So right now, general case, now we have something added to it so we can rewrite it. So on the circuit, we don't know what's on it, but we know something's going to be on it plus a microwave. So a microwave uses 1100 watts. That all has to be less than 1800. So that is the first part, the equation. Second part is solving the equation. So subtract 1100. Oops, make sure it's 1100. Subtract 1100. And x has to be less than 700 watts. So that's the second part up here because it does say write and solve. So again, you can do a number line for yourself and then test it. So again, if I put the arrows in there, something less than 700, this is what we're going to answer in the second part of the question is, what else can we put on here? So in addition to the microwave oven, which of the following appliances can you plug into the same circuit at the same time without overloading the circuit? So our answer, again, maybe a number line would help us here. If I do my number line, 0, I'm going to cheat, go right out to 700 minus 700. So again, it's an open circle, and then our arrowhead is there as long as the variable is first. So we need something that's less than 700. So right away, I see 1200 for the hot plate. That's no good because it's over 700. I see a toaster is 800. That's no good. I have a clock radio. That would work because it's less than. And I have a blender. That would work. That's less than. And actually, we could have both of those plugged in because 50 plus 300 is 350, and 350 is less than 700. So what appliances could we plug in? We can actually plug in 2 more of the smaller ones for this particular question. Question to change up, maybe only plug in 1. Or maybe we could plug in 3 or 4, just depending on what appliances we have over here. Thank you, ladies and gentlemen. Till next time.